You know that feeling, right? That little bump of turbulence, and you kind of peek out the window, wondering what's really going on out there. Well, today, we're pulling back the curtain on the incredible, unseen system that pilots use to navigate the weather and keep every single flight safe.
Okay, so imagine you're sitting right here, in the pilot's seat. You're thousands of feet up, and the whole world is just spread out below you. From this perspective, the sky isn't just a pretty view. It's everything. And it's an environment that can change in a heartbeat.
So how on earth do they do it? How do pilots fly through, around, and over these incredibly complex weather systems, day in and day out? The answer is this constant stream of intelligence, an unseen shield of data that protects them from the moment they take off to the moment they touch down. And that shield? It starts to get built long before the plane even thinks about leaving the gate.
Yeah, you got to think of every flight as a mission. And that mission begins way before the engines even spool up. The very first step is this supercritical phase of intelligence gathering, all done on the ground, where the pilot basically builds a complete mental map of the entire weather landscape for their trip.
And the cornerstone of all this prep is what's called the standard weather briefing. Now, this is not just a quick glance at your phone's weather app. No way. This is a full-on mission briefing with a specialist, and it covers every single potential weather threat. You could say it's the pilot's absolute first line of defense. What this briefing really does is tell a complete story of the weather for the entire journey. It's not just about what's happening at the destination. It covers everything: potential hazards at takeoff, what to expect during the cruise, and how things are looking on approach. It lets the pilot see the future, in a way, and plan for any challenges that might pop up. A huge chunk of that briefing comes in these coded messages that look, well, like this. To most of us, it's just a jumble of letters and numbers, complete gibberish. But to a pilot, this is a crystal clear snapshot of what the weather is doing right now. It's called a METAR, and it's a language every single pilot has to master.
So let's decode this thing real quick. Each little block of characters tells you something specific: the airport, the exact time, the wind speed, the current weather. In this case, it's telling us there's a heavy thunderstorm with rain right over Gregg County Airport. Boom. In just one line of text, the pilot gets a super precise picture of the conditions on the ground.
So if the METAR is a snapshot of right now, think of the TAF as the crystal ball. It's a forecast for the area immediately around an airport, and it predicts what the weather is going to do for the next 24 to 30 hours. This is what tells a pilot if they should expect clear skies or maybe a brewing storm when they get to their destination.
All this data is so incredibly detailed, which kind of brings up a good question. Where does it all come from? Well, it turns out it's sourced from this massive, global intelligence network that is constantly, and I mean constantly, monitoring the atmosphere.
It's really like a symphony of technology. You've got thousands of automated ground stations reporting what's happening on the surface. You've got satellites watching from orbit, and you have radar systems scanning the skies for any sign of rain or snow. But to really truly understand what the atmosphere is doing, you have to go inside it.
And we do that using these little instrument packages called radiosondes. Twice a day, all over the world, these things are sent up on weather balloons. They climb for up to 2 hours, sometimes reaching altitudes over 100,000 feet, all while beaming back crucial data on temperature, pressure, and wind. Eventually, the balloon pops, and a little parachute brings the instrument safely back down to Earth.
Now, back on the ground, the main storm tracker is the NEXRAD system. This is a powerful network of 159 Doppler radars that gives pilots a huge advantage. It doesn't just show where the rain is, but how heavy it is, and, most importantly, which direction it's moving.
And the system is amazingly versatile. In what's called clean air mode, the radar is so sensitive, it can actually pick up things like dust or even bugs in the air just to see these really subtle shifts in the atmosphere. But as soon as it detects rain or snow, it kicks into precipitation mode for a much faster, more focused scan of the storm.
But look, all the pre-flight planning in the world can't account for absolutely everything. Weather is alive, it's dynamic. So once a pilot is up in the air, their focus shifts to getting real-time updates, intel coming directly from the sky.
And this is where something called a PIREP, or a pilot weather report, becomes absolutely vital. I mean, forecasts and radar are great, but a PIREP is intel straight from the front lines. It's the only way to get a first-hand account of what's really happening with things like turbulence, icing, or the exact height of cloud layers, because it's reported by a pilot who is literally flying through it.
And just like the METARs, these reports are coded to be super efficient. This one here is telling air traffic control and, just as importantly, other pilots, that a Cessna flying at 6,000 feet is hitting some light turbulence in the rain. This one little report acts as a real-time warning, a pilot-to-pilot advisory that helps everyone else in the area fly a little bit safer.
For bigger, more widespread hazards, pilots get automated alerts. The two main ones you hear about are AirMets and SIGMETs, and the key difference is really just severity. An AirMet warns of weather that's potentially hazardous, especially for smaller planes. A SIGMET, though, that's a heads-up for weather that's hazardous to all aircraft. We're talking severe turbulence, volcanic ash, the really serious stuff.
So, with all the pre-flight data and all the live in-flight updates, the pilot has all the puzzle pieces. The final step is to put them all together, to use that intelligence to make strategic decisions and chart the absolute safest course through the sky.
A huge strategic tool for this is the Surface Analysis Chart. This gives pilots the big picture view. It shows them how these massive pressure systems in front are moving across the entire country. It gives them the context they need to understand why the local weather is doing what it's doing.
And today, all this information is more accessible than it has ever been. I mean, modern glass cockpits can display basically everything we've talked about right on screen. Live radar, text reports, in-flight alerts. It puts the entire weather picture right there at the pilot's fingertips.
But, and this is a huge but, there is a critical catch to all this amazing tech, and it's something every pilot has drilled into their head. The data has a delay. It can take a few minutes for those radar images to get from the ground up to a satellite and then down to the cockpit. This means pilots are always looking at where the storm was, not where it is. And when you're trying to navigate a fast-moving thunderstorm, that distinction can literally be a matter of life and death.
This entire system, from that first pre-flight forecast to the final in-cockpit update, it all forms this unseen safety net. It's a net woven from pure data that supports every decision the pilot makes, all the way to a safe landing.
Just think about it for a second. The pre-flight briefing, the coded METARs and TAFs, the NEXRAD scans, and those live PIREPs from other pilots, none of these things work alone. They are all woven together, layer upon layer, to form that powerful, dynamic shield of information that protects every single flight, every single day. So the next time you're on a plane and you're looking out the window at the clouds, maybe just take a moment to think about that incredible, unseen network of people and technology that's working around the clock, tracking every tiny shift in the wind, all to make absolutely sure that your journey is a safe one.